Hi there, Sergey Gegulov here for InfoWorld at IDG. In this episode of SmartPython, we're going to dive a little deeper into sets and learn how they can be used in more advanced ways. We started exploring sets in a previous video where I showed how they're collections of unique objects. I also talked a little bit about how you can add and remove items from sets. But sets have other, much more powerful manipulations that you can perform with them. They're a great boon when you want to filter or merge or compare groups of distinct objects very quickly. In this example, I have two sets, S1 and S2, each containing the titles of some movies. They have some elements in common and some not. And with them, I'm going to demonstrate the various operations that you can perform between sets. Now, if you've studied set theory in math, these operations ought to be really familiar. They're basically implementations of common operations in set theory. First up, we have unions between sets. This takes everything from both sets and merges them into a single set, removing any duplicates. This we do by way of the pipe operator. Note that the original sets in this operation and any other operations that we're performing, unless I say otherwise, are not changed. The result is a new third set. We can also derive the intersection of two sets. This is a set that contains everything that's only in both sets. In this case, the only common element is Blade Runner, and we use the ampersand operator to perform a set intersection. The difference operation takes what's in one set and returns everything in it that is not in the second set. In this case, we have two movies, Alien and 2001: A Space Odyssey, that are in set 1 but not in set 2. But we don't get Blade Runner because we already have that in both sets. To use this operation, we use the minus sign. Now, note that the order of the sets for this operation makes a difference. If we did set 2 minus set 1, we would get very different results. The symmetric difference operation gives us what's in set 1 and set 2, but not what's in both of them at the same time. Since both sets have Blade Runner, we don't have that in the resulting operation, but we get everything else from both sets. For this one, we use the caret operator, but in this case, the order of the operation doesn't matter, since we're just merging the two. Another operation that may sound exotic, but is really pretty simple, is the disjoint operation. All this does is test if both sets have nothing in common, and returns a Boolean value. S1 and S2 do have an element in common, Blade Runner, so for that we would get false. But I've created another set, S3, Alien and Solaris, and I've performed a disjoint operation against S1 with it, and that yields true because those two sets don't have anything in common. By the way, there is no operator that can be used to perform a disjoint. We have to use a method from the set type, as we see here. Subset is also pretty simple. It checks if all elements of one set are contained within another set. The set Blade Runner, S4, is a subset of S1 because we have Blade Runner in S1, so that will return true. And a set is considered a subset of itself, since all of its elements are contained within the so-called other set. To test for this, we would use the less than equal sign. Another version of subset is the proper subset. This is the same as a regular subset, except that the two sets cannot be the same thing. So S4 is a proper subset of S1, but S1 is not a proper subset of itself. To test for a proper subset, we use the less than sign. We also have superset and proper superset, which use the greater than equals and equal signs. And those, as you can imagine, test if one set contains all of the elements of another set, and the proper version of it requires that the two sets not be the same thing. Now I'm going to give a more concrete demonstration of how sets can be used. This script here takes two directories, two different installations of Python from the same machine, and creates sets from the files found in each of these directories. It then uses the difference operator to produce a set that contains everything that's in the Python 3.9 directory, but not in the older Python 3.8 directory. This is much faster and more convenient than trying to grovel through each directory separately and compare them manually. The print process takes far more time to run than the actual set operation does. Now we can also do the reverse. We can find all the files in Python 3.8 that aren't in 3.9. And we can use, in this example, the intersection operator to find out what files are common to both installations of Python. So to sum up, sets are best when you want to test for the existence of things in collections, or perform operations based on the presence or absence of those things in one or more collections. They're not substitutes for lists, because they don't guarantee the order of elements in them, and they're not indexable. But they're better than lists for finding out whether or not something is present in them, since you can test for the membership or presence of something in a set far faster than you can with a list. That's it for this episode. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel. And for more smart Python and more dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.